Our last conic section is the hyperbola. We are going to do the same things we've been doing with all the other shapes. We're going to look at what the graph looks like, what are the key features of a hyperbola, how do we write equations for it, how do we shift those graphs from having the center at the origin, and what are some applications for a hyperbola. All right. When we created the ellipse, remember we said we had two foci, right? And we put some string, locked the ends there, right? We talked about that. And we said that length plus that length has to stay constant. So if I go from this point over here and stretch the string, that's the same length of string, it's the same constant. Okay? With a hyperbola, it's not the sum of those two pieces of string that stay constant, it's the difference between the two pieces. Okay? So if we go from one focus to a point on our graph to the other focus, the difference between these two lengths is constant. All right, no matter what point we use. Okay? So, definition. A hyperbola is the set of all points in a plane whose distances from two fixed points in the plane have a constant difference. Those fixed points are called the foci. The line through the foci is the focal axis. The point on that focal axis, midway between the foci, is called the center. Now notice in this shape, the center is not inside our shape, right? It's in between the two branches. Okay? The points where the hyperbola intersects the focal axis are the vertices. So we have vertices here and there. Notice the foci are inside the curve, just like they were for parabolas and ellipses. Okay? We are still using an A value to get to the vertices. We're still using a C value to get to the focus, okay, from center to focus. So that's the same as what we had with an ellipse. The one difference is that in a hyperbola, we don't have those points called covertices, right? We still use the B value to help us make our graph. I'll show you that in a minute, but we don't label them covertices anymore. Okay. Also, I guess it's on the next page. There's another picture. So here we've got two options. We have two branches that curve sideways, like in our first one, which means we have a horizontal axis here, all right, vertices here and here. Notice that our branches go through those vertices, and they are approaching these diagonal lines that we call asymptotes. You're used to horizontal and vertical asymptotes, okay? These are just diagonal ones. We're going to look at how do we get the position of those asymptotes because they're really critical for graphing our hyperbola. All right? The only other point that we actually plot that's on the hyperbola is the vertex. So we can't draw the branches with just knowing the two vertices, right? We have to have some lines that we aim at. Okay? So we're starting out with it centered at the origin. We have a couple basic equations, again, one where there's a horizontal transverse axis and one where that's vertical. They look similar to an ellipse, don't they? What's different about them? Think about your ellipse equation from the last few days. How is this different? There's a subtraction sign in between, right? Still equals 1. We still have x squareds and y squareds on top and a squareds and b squareds on the bottom. But there's a minus sign, okay? That's going to be your clue that it's a hyperbola. Bless you.
God bless you, sir.
The only conic section with a minus sign in the formula is the hyperbola. Okay, so that's going to help you figure that one out. Notice on this that in both options, the vertical and the horizontal, a squared is first, b squared is second. In an ellipse, we said a and b could flip-flop, right? And how did we know which one was a? It was the bigger one, okay? In a hyperbola, your a's and b's do not flip-flop. A is always first. It's not necessarily the bigger number anymore, but we know it's a because it's going to be in the first position. Okay? So you'll notice that on top the x and y's flip-flop. Okay? If a is paired with x, our vertices are going in an x direction and our branches curve around that x-axis. Okay? If A is paired with Y, now our vertices are measured out in a Y direction, and so our branches curve around a Y axis. Okay? So highlight this. A is always first. Also notice the relationship between your A, B's, and C's. In an ellipse, we had A squared minus B squared equaling C squared. Now we have A squared plus B squared. Okay? The way I remember it, if there is a minus sign here, there is a plus sign here. It was the reverse for an ellipse. We had a plus sign up in our formula. We had a minus sign in our Pythagorean relationship. Okay? So just know that they're always opposite. All right, a couple more terms. In an ellipse, we called it a major and minor axis. Okay, major was the longer one, minor was the shorter one. A couple different terms here. This time it's called transverse and conjugate for our axes. So they're defining chord because chord is used in the other two definitions. A chord, remember, is just a segment that has endpoints on your hyperbola. The transverse axis is the chord lying on the focal axis connecting the vertices. It has a length of 2a. The conjugate axis is the chord through the center perpendicular to the focal axis, kind of like our minor axis in the ellipse, okay? But we don't have covertices in a hyperbola, so we don't label those endpoints anything, okay? If we split them in half, we have the semi-transverse axis, which would have length a, and the semi-conjugate axis, which would have length b. Okay? Once again, they've summarized everything in a chart for you. We are going to ask you to list some key features, just like with the ellipse, we made you list vertices, covertices, and foci, right? With a hyperbola, you are going to be listing vertices and foci. We don't have covertices anymore. But we also have these asymptotes, those diagonal lines that we're approaching. So we are going to ask you to write an equation for the asymptotes. Okay? Starting out with it centered at the origin, that means the y-intercept is 0. So we can think of this just as y equals mx. We don't have a b term. Okay? Notice that one of your asymptotes is going to have a negative slope and one is going to have a positive slope. Okay? And we use a box to help us figure out where to position those. Okay? So when you go to draw a hyperbola, you are going to measure off your a's and b's. All right? Look at your equation. Is a paired with x or y? That's going to determine which way we measure it out. But we're going to make a box connecting those a points with our b points. Okay? So each side of the box is going to have that as its midpoint. And then the asymptotes are just the diagonals of that box. Okay? So it's fairly easy to figure out where they are. All right, let's try one. It says find the vertices and the foci for this hyperbola and graph it. I am going to add in there that I also want you to give me the asymptotes. Okay? All right. From our equation, what's the first thing we would have to do? Get one side equal to 1. Yes? So we're going to divide everything by 36. What equation do we get? X squared over 9 minus y squared over 4 equaling 1? Okay. What do we know from this? A would have to be 3. How do I know that? Because it's the first one, not because it's the bigger one, because it's the first one. Okay, A is 3 and it's paired up with X. B equals 2 and it's paired up with Y. Yes? Okay, let's go graph that. We have 3 in the X direction, centered at the origin again, right? We haven't translated anything yet. So from the origin, we're going to go 3 in the X direction. So left and right 3. And I'm going to have you label those with a V. Okay? You're definitely going to want to label those points because your hyperbola has to go through the vertices. All right? So put a V next to them so you remember those were your vertices. We're going to go 2 in the Y direction. Okay? I'm not going to label those anything because my graph isn't actually going to touch them. They're just there to help me make my box. All right, so we want to make a box that has these 4 points as the midpoints of the sides. Okay? So we're going to make a box like this. I usually make it dotted, but my smartboard isn't working very well with dotted lines. So we'll make it solid. You want to draw it in lightly, make it dotted. It's not really part of your answer. It's just helping you get the right position. Okay? Then you want to draw in diagonals of that box. Okay? And to get how wide the branches are, we know that our hyperbola has to touch the vertices, and those diagonal asymptotes are creating lines that I'm approaching. So I'm going to have one branch over here approaching those dotted lines, okay, getting closer and closer to them, making sure that your hyperbola branches touch your vertex. Okay. Now, we've got our picture drawn, but we have to go back and give the information that they asked for. What would the coordinates be for my vertices? Perfect. Okay. And again, when it's centered at the origin, we can combine those just into one ordered pair, even though it represents 2. How about foci? How would we find those? What letter do we have to know for foci? We have to know C. How do we find C? Which one is it? A squared plus B squared equals C squared. So C is going to be the square root of the sum of those two. All right. So we've got A squared being 9 and B squared being 4. So C is going to be the square root of 13, which is about, okay, a little smaller than 4, right? All right, so our foci are going to be about here. Not quite to the 4 mark. How would we label the coordinates of those? Yes. Okay. All right, and then I also said I want you to give me the equations for the asymptotes. So because this is centered at the origin, we don't have to worry about a y-intercept. We just need to figure out the slope. So use your box, all right, to go from our center to the corner here. How much did we rise? We rise 2 and we run 3. So that's my slope, 2/3. So y equals plus minus 2/3 x. It's plus minus because I have one line that has a positive slope and I have one line that has a negative slope. Let's try one more of those before we start translating stuff. It says to find an equation for the hyperbola. If the foci are at 0, -3, and 0, +3. So if we think about where those are on the graph, what does it tell me? What information is that giving me? It's telling me C is 3, and it's going in which direction? It's going in the y direction. Okay? Then it says the conjugate axis has a length of 4. Which one was the conjugate? That's the B piece, right? Transverse axis is your A, your vertices. Conjugate is the B part. So we have 2B has a length of 4, the whole conjugate axis, so its semi-axis would be 2. B would be 2. All right, now, if C is going in a y direction, that means A also has to go in a y direction, right? Your vertices and foci are always lined up. So we know that A is going to have to go with y. C went with y. B has to go with x. Okay? All right, let's find A. We know that C squared equals A squared plus B squared. Yes? Okay, so A squared plus B squared would be 4, and C squared is 9. So A squared has to be 5, so A would be √5. You good with that? Okay. So we know A, B, and C, and we know which direction they go in. We've been asked to write an equation for it and also to sketch it. Do we know enough to write the equation? We do. In our equation, we have something minus something equaling 1, right? A fraction minus a fraction equaling 1. A is always going to be where? In the first position. So my A squared here was 5. 5 is going to go in the first position. And we said A was paired up with which variable? Okay, so we're going to have y squared on top. And then B squared was 4. It'll go in the other position, and it is paired up with an x. Okay, so we've got our equation. Let's go ahead and sketch it. We've got our vertices drawn in. No, we have our foci drawn in. All right, vertices. How big is our A value? A was √5, which is about a little over 2. Yes? All right, so let's go in the same direction as the foci. Our vertices are just going to be a little over 2. All right, so close to our foci. We can go B units in our x direction. Again, we don't label those anything. We're just using them to help make the box. Okay, so we want to make the box that connects the blue and green dots up here. And then draw in our diagonals. Now, do our branches go on the side or do they go on the top and bottom? They have to go through which point? They have to go through V, right? Through your vertex. So our graph is going to be top and bottom, touching the vertex and approaching those diagonal lines. Okay. All right. We've got our equation, we've got our sketch. what are the asymptotes? We have y equals plus or minus our slope times x, right? What's the slope? Go from the center out to a corner of your box. Okay, so from 0, 0, we went up how much? We went up root 5 and we went over 2. So root 5 over 2. Questions about that? All right, we're going to shift everything. Again, they've summarized it all in a chart. It's the same transformations we've been doing for all of our shapes. Okay, so instead of an x, we have an x minus h. Instead of a y, we have a y minus k. All right. Look at your asymptote equations at the bottom here. I'm going to rewrite this a little different way. I'm okay with either option. If you think of it this way, we've already been looking at y equals plus minus mx, right? We can find our slope based on our box that we've drawn. So I don't think it's critical to memorize, do I need b over a or do I need a over b? I'm just going to look at my picture. Okay? Also in our equation, we have an x minus h. Well, it's right there, right? It's going to be part of that equation they're giving you. Y minus k is right there. So all they've done is they've moved the k over here to the right side. They've added it to the end. I'm okay with either version. Okay. All right, we got a couple to try. They've again given you those same original pictures, but shifted from being centered at the origin. Our steps are the same that we've been working with all along. Plot what you know. All right, put that information on a graph so you can see it. Make sure you know where the center is. We have to know HK, whether we're going to graph or whether we're going to write an equation. All right, we need to know A, B, and C. Put that information on your graph and sketch it, and use that information to help you write your equation. All right. It says, find the standard form of the equation for the hyperbola whose transverse axis has endpoints -2, -1, and 8, -1. What do they mean by the endpoints of the transverse axis? Transverse was like what in the ellipse? Yeah, it's like our major axis, okay? So transverse axis is connecting a vertex to another vertex. So they've really just given you the two vertices. Okay, so let's put that information on our grid. We have one vertex here, and we have another one here. So what does that help me find? Helps me find A. Okay, so how far apart are those 2 points? They're 10 spaces. So where would the center be? Center has to be in between them, right? Halfway in between. So if they're 10 spaces apart, if we went 5 from either side, okay. That puts my center here at what point? Okay. We have to know that to write the equation. That's our H and K. What else did we figure out from that first piece of information? We know A. A has to be what? 5. Okay? And it's going with which variable? It's going in our x direction. Okay, so we know that we're going to pair A and x together. We know our center point. Then it says the conjugate axis has a length of 8. What does that tell me? That what's going to be 4? That's our B term, yes. The conjugate axis is basically 2B in length. All right, so that means B has to be 4. And if A went with X, then B is going to go with Y, in the Y direction. Okay, so let's mark off 4 in the Y direction from our center point. Again, I'm not labeling those anything because my graph isn't going to touch them. Why do we plot them? Why do we plot those B pieces? So we can make our box, and the box leads to our asymptotes, which helps us draw our graph. Okay, so draw in your box. Go ahead and put your diagonals in. Does it want to move for me here? Okay. Which side are we going to draw the branches on? Left and right. Okay, going through the vertices. Approaching those lines. And going through our other vertex. Okay. It says to find the standard form for our equation. Do we have the information we need? Okay. Our basic equation for a hyperbola. What's under the first fraction? A squared. A was 5, so A squared is going to be 25. It's paired up with which one? X. Now remember, we've shifted this, right? So we're going to have X minus H. Okay. And then in our second fraction, we need B squared on the bottom, which would be a 16. And that's paired up with Y. Yes? So now we just have to dump in our center point. We said it was 3, negative 1, so we're going to have X minus 3 and Y minus a negative 1, or really Y plus 1. Okay? All right. Last thing I want you to do on this one is practice writing the equation for the asymptote. So remember, it starts out y minus k equals plus minus some slope times x minus h. Okay? And then if you want to move the k value over here on the end, on the right side, you can. It's not required. Okay? So from our equation, what y piece do we have? Right? We had a y plus 1. That's going to go here. From our picture, what's our slope? We went up 4 and over 5. Okay? So 4/5. And then from our equation, we also have x minus 3. Okay? All right, last one. I'm going to pause the recording, let you guys try this one at your tables. All right, let's check through our work. Did you get a center of negative 2, 5? Yes? All right. We've got a being 3. It's coming from this a squared of 9. It's paired up with x. We have b is 7, and it's paired up with y. Okay? Using the 9 and 49, we're coming up with the c value of the square root of 58. Is everybody okay with that? All right. To find your vertices, we have to go a spaces from the center. A was 3 in the x direction, so from my center point, I moved 3 on either side in the x direction. I listed it like this because we are changing the x coordinate of our center point. Okay? Now, if those are nice integer values, go ahead and simplify it. Right? -2 plus 3 is 1, and -2 minus 3 is -5. So we can get our two vertices. But when it's not a nice integer value, you're going to go ahead and leave it like I did here for the foci. It's -2 plus and minus the square root of 58. Okay? Notice that your branches are very long and stretched out. And notice that your foci are farther away from those vertices. Okay? It's a much more stretched out picture than the other ones we've looked at. Asymptotes. We've got y minus 5 equaling plus or minus our slope. We are looking at our box. Our slope is 7/3, and then times the x plus 2 piece. Okay? Questions on that? All right. There's your first assignment.